Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 151, Permutations 4. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, honestly, I thought it was pretty okay. This is, the ideas that I'm going to do is pretty standard-ish. It's off standard in that it is a variation on standards, but I don't think this is so bad. First of all, the first thing to notice is that the first number, of course, is very important because the first number means that the rest of the numbers, like if the first number is odd, then the second is even and so forth. And additionally, the way that I would think about it is actually, instead of n factorial, because you have n numbers, n factorial is number permutation, it's actually two sequences, right? One is the odd ones and the ones in the even indexes, and then combining them in some way. So it's like, roughly speaking, n over 2 factorial squared. Of course, there's some stuff about odd, even, and all these things, but yeah. So I'm going to go over the code, even though usually I talk about this a bit. But the reason why I want to go over the code is because I think this is, like I said, a roughly standard thing. I think if you struggle with this one, make sure you understand the easier permutation problem first. I don't know, I mean, maybe it's permutation 1, maybe it's permutation 2 or 3, but there probably is one where it is just find a kth permutation in lexicographical order, right? So I want you to, if you have questions about this one or struggling with this one, work on that problem first. I probably have a video about it, so you can kind of think about it. And this is basically the same idea. The idea here is that we just try each number one number at a time. You could use some maths and stuff like that to make that process easier, but I think that is the most foolproof. And as long as the complexity makes sense, the one that it solves a lot of different type of problems that are similar to this one, where you have to get the kth number in lexicographical order, right? And the way that I think about it is that, like I said, brute force one number at a time. For example, we may want to try, okay, what's the first number, right? Let's start with 1. If the first number is a 1, how many numbers are in the rest of the series, right? Meaning that, and we can kind of, I was going to bring up the drawing board, but maybe I don't need a drawing board. Maybe I could just ask you, right? I mean, another way of thinking about it is, let's change the problem to a really dumb problem for a second, right? And what I mean by that is that let's get, I think this is an easier way to learn is, let's say you want to get, I don't know, I'm just banging on the keyboard, this number, so k is equal to this, but for a different problem where it is a base 10 number, right? Well, okay, this is a very dumb example, as I said, right? Because then a base 10 number, let's say that we have 6 digits, right? We go, okay, is the first digit a 0? Well, if the first digit is a 0 in a base number, well, how many numbers are there with the first number being 0? Well, it goes from, the rest of the numbers go from this to this, right? So that means that there are 100,000 numbers, right? Okay, so that means that because k is after this, we know that, well, the first number cannot be 0. The second number, the first number has to be well, it doesn't have to be a 1, but we go, okay, is it possibly a 1? Well, there are all these numbers that goes in here, right? And then that's also another 100,000. There are two ways you can think about this. You can say, now, we know that it cannot be 0, so we remove the first 100,000 numbers, so then now we're looking for this number, right? You could also do like a cumulative sum kind of thing. It's mathematically the same. But here we know that, okay, there are 100,000 numbers in that range, so 24,000 numbers. We know that this is going to be inside. So we know that, okay, then we don't have to do this. We know that the first digit is a 1. And then what is the second one, right? Well, is the second digit a 0? If the second digit is a 0, then it goes from this to this, right? And we have about 10,000 numbers. That's no good, right? So then we maybe subtract the first 10,000. So now we have 14,000, but now we know that the first number is not a 0, so we try a 1 maybe, right? Hopefully you see what I'm trying to do here, right? Like I said, if we're doing a base 10 number, this is really stupid. You can just be like, okay, look, Larry, we have this number. Of course, this is the number. I mean, -1 maybe, but you know, of course this is the number, right? And you can actually, you know, use this idea for non-base 10 numbers as well, right? You could do maybe base 8. You go, okay, well, the first digit goes from this to da. So that's actually, I don't know what it is, but it's 8 to the 5th or whatever it is, right? Or maybe 8 to the 6th. No, oh, it doesn't go to 9. So my fault. Sorry, right? It goes to something like this because it's base 8. So you have 8 to the 5th, right? And then is that big enough, etc., etc. You can do the math. So permutations is the same thing, and that's basically the way that I would do it. Except for that, of course, calculating this 8 to the 5th or 10 to the 5th or whatever, it's a little bit trickier, right? For example, here, let's just say we have, okay, fine, right? So let's say maybe in this problem we have n is equal to 5. K is equal to, I don't know, let's just say 20. I don't know if that's easy enough to do, honestly. Then now we go, okay, well, is the first number a 1, right? Well, if the first number is a 1, then what are possibilities? Actually, I'm going to reduce this to a 4 just for easy. It's 3 and a 4. So these are the rest of the numbers. So how many sequences are there with these numbers left? And of course you have to keep one more thing for this one, which is that the first number is odd, so that means that the first number for the rest of the sequence has to be even, right? So maybe you have this thing, right? And then now we have this thing. How many numbers are there? Well, the short answer is we'll show you how I do it later, but you can also just, you know, write this out, right? The next number could either be a 2 or a 4, right? So here we have 2, 3, 4 or 4, 3, 2, and that's it. So that means that if 1 is, maybe 20 is too big now, I don't know. Maybe, okay, let's do 5, right? So then now we have a 5. So then now we have either this or 2, 5, 4, 3, or 4, 3, 2, 5, or 4, 5, 3, 2, right? So there are 4 numbers. We know that the first number is not a 1 as a result, because, you know, there are only 4 numbers afterwards. So then now we try a 2, right? And of course now we know that it's not in the first 4 number, so we find the 16 of the rest of the numbers. And here the first number is even, so it has to be an odd, right? So then now you have 1, 3, 2, 5. Unfortunately, I did say 4 or 5. I don't know why I wrote, but yeah, but this is the right one, right? And of course, this is actually impossible, right? Because there's just not enough numbers. It goes odd, even, odd, and then there's another odd, right? So actually, it's 0. So then now we go, okay, is the third number a even, right? And again, you have the same thing-ish. So there's gonna be 4 different copies, etc., right? So that's basically the idea behind this this problem. Is that we just try one at a time. And then after you get the first one, let's say, I don't know, let's just reduce this to like a 2, right? Then now we go, okay, well, now we know that the first number is a 1, then what is the second number? Is it a 2? If this is a 2, then you have odd, the next number is an odd, you have 3, 4, 5, and there's 2 possibilities. And because there's a 2, that means that the first number is a 2. That's basically the idea of one at a time. And there are a lot of things you can realize from here, but instead of kind of, and there are things that you can do with math, right? Because as I said, like similar to what we had when we had base 10 or base 8, which is like 10 to the 5th or 8 to the 5th, you probably can do some math on calculating how many things there are here, right? Because here, given that this is even, this is actually n over 2 factorial times n over 2 factorial, right? And in this case, this n is 4, so it's 2 factorial times 2 factorial, which is 4, which you can calculate. But of course, this is a little bit tricky if you ask me, because like I said, if you even just change this to 2, odd, 1, 3, 4, 5, I mean, it's not that hard, honestly, but for me, it's just more edge cases to consider and more possible wrong answers, right? Because now you have, it's not 3 factorial times 1 factorial, for example, right? So yeah, yeah. Yeah, okay. That's basically what I would say about this part. And some part of it I am, you know, I'll talk about it in a bit, but Python does let me get away with some stuff because even 100 factorial is not that big, but yeah, it's okay. But yeah, and as I said, this problem can probably be easier, but I definitely write or easier. Sorry, not easier in the sense that it's easier, but similar in terms of complexity, or not even complexity, but just like you could reduce this a bit. But the reason why I want to show you this code is because that's how I wrote in the contest, and the way that I wrote it is in a way such that it is deliberate, that I don't have to think about things, if that makes sense. Because you can definitely clean this code up and make it shorter by thinking about things. Like I said before, like you can reduce some if statements to like n factorial, from n numbers to like n over 2 factorial square or something like this, or some if cases. But you'll see that I actually calculated out for the reason of I don't want to think, right? And you'll see I'll go over it as I see it. But yeah, so let's go over here first. This is the first number, the first digit. You'll see that I kind of need to do more of it, but this is the first digit, right? And the first digit is just, first I just keep track of what I used. You actually technically don't need to do it this way. There are other tricks you can do, but this is the way that I did it anyway. But yeah, so this is used, right? Answer, this is just our answer thing. So for every number without loss of generality, we actually can use this as a 0 index thing instead of 1 indexed thing, and then just convert it at the end. Like this is why I have it here. But so if that part looks confusing, but it's fine, right? So yeah, so we brute force try the first number, right? Try the first number. Try for the first number, and we set the first number as I by marking as used, and then we just go, okay, well, if it's even, then the next number is odd, right? And maybe I could write it out. Is odd is equal to, well, technically this is it's even, but then here we want, and yeah, this looks a little bit odd, weird for a second. We'll go over it. But basically this is just counting. Okay, well, I just need a function going, if the first digit is I, how many numbers, how many permutations are there for the rest of the numbers? And then this is just, if it's greater than k, then that means that this has to be the first number because it's inside the range that we count, right? What we talked about. So we append it, we break. Otherwise, we subtract and then we set it to false and we go again for the next number. Okay, so time to go over this thing. Yeah, there are simplifications that you can do, like I said, but we'll go over how I've written it during the virtual contest. And this is that the next number is odd. Well, with the next number is odd, the way that I thought about it is that, well, the numbers themselves don't really matter. It's just whether number of odds and evens left, right? And it turns out that this function is actually like very whatever, like if you're at a certain index, like what I mean to say is that if you, for example, if the number that we're trying is a 1 and the number that we're trying is a 3, this function actually does duplicate work, is what I want to say, or this part of the function anyway, because I don't know, I just want it to be lazy, right? But what I mean by that, for example, is that like if we have, as we said, 1, 2, 3, 4, 5, right? If the next number is 1, we have 2, 3, 4, 5. And if the next number is 3, we have 2, 1, 4, 5, kind of. And both of these cases have 2 odds and 2 evens in terms of all the permutations. So it would give you the same answer, but I kind of wrote it this way because I didn't want to think about how to clean it up. Because I know that this is correct, so I didn't want to think about it. And of course, the reason is because this is an O of n loop. And n here is only 100, right? So I didn't have to worry about the saving that time, and we only call it n times here, so you can think about this being roughly n squared, but also this is very fast, where it's just an if statement and a lookup. So that's basically why. This is one of the things that I said you can simplify so that you don't reuse things, but I just didn't want to, like I said, during the contest, I knew that it'll be fast enough, so I wasn't worried about this part, right? Anyway, and then now we have a function that actually counts, okay, if the next number is it's odd and there's even and odd things, right? Then what is the number of permutations there are? And here, as I said, you can not even probably, there is a closed form for this, but I worried about the honestly, I did worry about the if statements and all these things, right? So I just kind of did it this way, and which is that, okay, if there are too many, if it's too unbalanced, then it's going to be just 0. So I don't even think I needed this because of the way that I did the other parts, right? But basically, if even and odd is equal to 0, then we return 1, right? Hopefully straightforward, because that means that we use every number perfectly. If one of the numbers is negative, that means that we ran out one of the negative numbers because they have to all be alternating. Like I said, you could special case, you could if statements case study it away, but I just thought these base cases are much cleaner to think about. Okay, if it's odd, then we have odd number possibilities, and then this is just a recursion, right? And of course, this recursion, like I said, is probably going to come out to n over 2 factorial square, but with variance on like odd, even, and depending on inputs, right? So that's why I kind of wrote it this way. Like I said, it's not important, but you know, like you can simplify this function, but this is the way that I did it because I knew that it'll be fast enough. Yeah. And hopefully this recursion is very straightforward, and we just kind of slap a cache on top. Why? Because it's odd, it could be only odd even, so there are only 2 cases. Even can only go up to n over 2 anyway, but let's just say n for big O, right? So O of n. So this is just O of n squared, where n is 100, right? So that's why I didn't really think about this function, and this is additive, right? Meaning it's you don't multiply this n squared by anything, right? It's just the total cost of calculating all of them. You can kind of prove it to yourself by just pre-calculating this, right? Like if you write a for loop for I in range of n, for j in range of n, you could pre-calculate this for false or true, ij, fcount true, ij. If you write something like this, then all the inputs, other than I guess the negative cases, would be pre-calculated, and it would just be O of 1, right? So that's how you know that you could take, like, there's no multiplicative factor. But yeah, and that's pretty much it. That's the core idea, and I didn't really aim to write clean code. I mean, I think this is clean for what it is, but like I said, you could write simpler code for sure, but why bother when it's fast enough, right? And I said, yeah, and so that's what I did for the first number. If there's none, then that means that we ran out of numbers on the first digit, so we just return empty array. Otherwise, we know that the first number is I. That means that there will exist an answer. So then now we just go for we just kind of loop for the rest of the indexes one at a time, and for each of those we try every n. If it's not used, and of course we have to keep track that, you know, the parity, the odd evenness is different. We just brute force try it. This is the same as before, whether the next number is odd. And again, you can reuse some of this, but like I said, I don't really care about it. And yeah, and if this is within, then right? And that's pretty much it. The complexity is going to be n squared, where n is 100. So really not a big deal. I think the tricky thing about how I wrote this, though, it is that it is Python specific. And why I say that is because as a reason of calculating this, you may get 50 factorial square, right? And that may be, over, that may be overflow, right? You can, in other language, you can hack that. It's a little bit annoying, but you can. It's just, just calculate the number until it overflows. I don't know what it is actually. Maybe like 20 or something, 15. I don't know. Because k is only 10 to the 15, so you only need this up to like 15 or something like that. This is off my head, so maybe I'm off by a couple. So yeah, and then if even is greater than 15, then you might as well just return infinity, because because it will always be smaller, is my point. yeah, and for example, if you have 100 numbers, I'm sure if you have 100 numbers and you have something like this, the first 20 numbers is going to be like, you know, like we can even test that. I suppose will be just like the first few numbers, right? Like there's really no way around it, right? And why I said there's no way around it, yeah, it's because you just don't have enough numbers, right? So the first, actually, a lot of numbers are basically just straightforward, right? Like it gets up to like here before it even changes anything. I think maybe I'm wrong, but yeah, so you definitely could do some if statements there. Yeah. So like I said, the complexity is n square. You have to be a little bit careful if you're not using Python or big nums. But yeah, this is the first. This is to get the first number, if statement. This is to get the rest of the digits. I convert it from 0 base to 1 base. Also, subtract 1 so that I count them on 0 index. And yeah, and this is the function to count if the current number is I, how many numbers are left. This is, I mean, this is DP, but like I said, you could closed form this, but I didn't. Like these things you can do by thinking, but I didn't want to think. I knew that this is fast enough, and you know that's what I have. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live during the contest next. I thought I got this very quickly and should have been with no wrong answers, so that's actually pretty bad. But Q4, a lot of people got. I forgot people cheat, so yeah, okay, never mind that. The leaderboard doesn't matter anymore. Especially for virtual, but all right, let's take a look. Given denominator, alternate implementation, no adjacent elements are both odd and even. Okay, we've done the cave. Okay. Huh. 590 people got this one. I mean, the only two things, right? It's just whether there's the odd indexes and the even indexes, and then you just have the first number determines the rest. So then now it's just n n is equal to odd is a little bit. No, that means that even numbers cannot be in the beginning. That's just the same, right? So that means that you have n factorial over n over 2 factorial over or times n over 2 factorial or whatever. Pretty basic, right? And it's just counting. N is equal to 100 anyway, but I mean the idea is basic. Can we implement it? I don't know. We'll see. Okay, so then now we want to see. And all right, let's focus on the even case first. I mean maybe it's not that bad, honestly, but yeah. Okay, so if this is even, then we want just n factorial square. So then we want the k part is a little bit tricky, isn't it? I mean, it's still a little bit tricky, but because we have to combine two thingies. Okay, so I mean. I guess this doesn't matter then. Right? Then now for I in range of n, oops. Then now we go. Yeah, I mean it's just n times n, right? it's so annoying to implement, but I don't think it's that bad. Then it's just count. How do you count precisely? Interleaving, right? So you have n over. Okay, yeah. I mean, right? So then now for I in range of n, maybe one, right? So then here we have some function that's count. I just give it 0 index. I think actually it doesn't matter. And then if not use I, then we want to try it, right? So we do a count, right? We want to count. Okay, yeah. We have to do something. The first number is always a little bit weird, actually. So maybe we'll special case it out because of the odd even parity thing. But it's not so bad. Okay, so then now, I mean, this is never going to be used. So then count. Right. So if I want 2 is equal to 0, then we count where the next number has to be odd, right? So maybe something like so then this is true. We want to say used of I is equal to true. Yeah, maybe this is a maybe, but not here. I guess we just subtract k, right? So that's fine. Yeah, okay, that makes sense. We just subtract from k directly. Okay, so then now we just have to count. So then now it's odd. So then the first number would be I. So then the next number has to be E. The next number is odd, right? So then we just count the number of odds. I can probably cache this actually. I could probably actually, the way you should do it is probably write this in a cleaner way, but because there are a lot of things going on, but I'm writing in a dumber way just to kind of be a little bit better about it. So then now we can turn because you can these things are only delta on one item, so these are all like basically the same, but I just want to write this is also fine because n is 100. So f count for the function of even odd, right? Even odd. So then we have to do is odd. So then the next number of is odd, right? I don't know how to write infinity in a good way. Maybe because here we want to write 2, that would be too long. Alright. 2, you have two odd and one. So okay, so is that always only to be the case? Maybe not. I don't know. Okay. If now it should return 0 because there's no possibility, right? Okay, that makes more sense actually. And then the next number is going to be odd. All right, so it's just return odd. You can choose any of those odd numbers times f count of not is, oh wait, I guess it should be if it is odd, then we have to return this. That means I need a base case, so I'm going to do it recursively. So now it's even, odd minus 1. And again, I probably didn't need to write this way, but that's fine. Oops. Okay, so then now if even is equal to 0, well, I guess I have to make sure the parity makes sense. So if is, I guess this is the base case. If odd minus 1 is equal to 0 or less than 0, but we need to return 1 somewhere, right? So okay, so I think actually if even is equal to 0 and odd is equal to 0, then we return 1. I think maybe that's the only base case, right? Okay, so then now if current is K1 indexed, they should just make it clear. I don't know why they don't. I mean, I guess it's here, but they should just make it clear. It's just so easy to just write one line on it, especially when Leetcode is inconsistent. Okay, so then now if it's greater than or equal to K, then we break and the first to be I, right? Okay, and then now from 1 to n, we will get the rest of the digits for I in range of n. If I mod 2 is equal, wait, why did I write it this way? Oh, because of the count true. What I should write it is here. That's why. That's confusing. Mod 2 is odd. So if this is true, if this number is even, then the next number is odd. Okay, so that's fine. Okay. And then now is not equal to the last number, mod 2. Then we do the same thing, right? So use of I is equal to true, maybe current. Oh, no, that's fine. Oh, I did miss. Otherwise, K. Try current, right? Same idea, actually. Pretty much the same. Oh, I also have to check that it is not used here. We didn't have to do it before because, you know. Oh, brick is brick fine? Brick is fine. Okay. I think this is roughly right, maybe. I didn't handle the impossible case yet. This index out of bounds. Is it I? No. Oh, it's this thing. Maybe that's the case for the impossible case, actually. Length of n is equal to 0, then we just return. Okay, well, that's that's not great, but that's okay. Maybe this implementation as well. Did I mess this up? Why is this way? Okay, copy and paste error, maybe. Okay. What's the answer? I mean, it's wrong, but there's a weird impossible case that I'm not handling here. I was feeling a bit off on this one. Well, that's fine. Because basically, yeah. No, that changes things. Okay, well, I mean, we didn't even get this one right. So, okay, I mean, I think we're in a good, well, I don't know, we're in a good place, but we're in a place, and that is exciting. Oh, 111, right? 0, it's saying that there's, if we put 0, there's one digit, one number. Is that true? Oh yeah, that is true. But, oh, I just did that one. I think we need. So that means that there's too many. Maybe this is strictly greater than. Maybe I'm off by one in some places actually. Okay, let's think about this before. Let's look at this one real quick. So 0, there are two numbers. If it thinks to 0, yeah, this has to be 3, and there's 2, so that's right. 1 is the next number. 1 has 2. Do I subtract? No. I have to print K. That's what I want. Okay, so then we try the 2, and nope. So we want the 1 index of this, of the second number. Yeah, so I mean the first number is right, so maybe it's just in this part and I'm off by 1 somehow. Like this part, I'm not quite sure about this actually. If maybe it's this part, because if it's K, then we want to get 0th element. Maybe that's a little bit more sensible. I mean now it's right, so I guess that was it. Alright, yeah. I mean, or I don't know if it's right, but it is accurate. We just have to convert everything by incrementing by 1. So something like this, and at least it matches the answer. Yes. Whew. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.